your ability to relax lies the parasympathetic nervous system. It's the counterbalance to your fight or flight response, signaling your body to slow down, digest, and heal. And the key to unlocking the system, the vagus nerve. The vagus nerve is like the body's superhighway, connecting your brain to your heart, lungs, and digestive system. It plays a central role in controlling vital functions, such as slowing your heart rate, improving digestion, and regulating your immune response. This nerve also helps shift your body into recovery mode by activating the parasympathetic system, which promotes calmness and healing. Meet NeuroSim. This non-invasive, wearable vagal neuromodulation device is a product of 10 years and $10 million invested in research efforts in collaboration with neuroscientists and clinicians from world-leading academic institutions. Minutes per session. During the day, the NeuroSim device restores natural energy, focus, and stress resilience. At night, it helps you fall asleep faster, sleep deeper, and wake up refreshed. It speeds up recovery. Unlike other methods, the NeuroSim device regulates your nervous system effortlessly and is the most studied wearable vagal neuromodulation system in the world.
For thousands of years, the elusive and mysterious gods of ancient Egypt have watched over the land of Kemet, keeping their people safe from harm's way. Of all the deities, none are held to such a high esteem as Ra, the god of the sun. Join us in this video as we venture back to a time of the Great Pyramids, prior to the construction of the elegant temples that dot the Nile's valleys, to a period when the gods themselves walked through the sands of Egypt. Here we'll explore the unique origins of one of Egypt's most revered deities, to some, the creator of all gods who harness the power of the universe. This is the story of the mysterious and all-powerful Egyptian deity, Ra. Ra, consider a creator deity. Ra is one of the oldest and most powerful ancient Egyptian gods. According to legends, he is said to have been self-created, a god who formed himself from the vast nothingness during a time before the universe. Every other deity in the Egyptian pantheon is considered a direct descendant of him. In ancient times, Ra's name was associated with the sun, but as with most deities, he had more than one name. Sometimes he was referred to as Amun-Ra, Khepri, or Adam. Each of the individual names was associated with the various aspects of Ra's totality. As time passed in Egypt, new dynasties would create new names for older deities as they assimilated them into distinct belief systems. Ra was undoubtedly the most famous of all Egyptian deities of old. He was the god who presided over the sun, allowing the rays to bring forth a bountiful harvest. Ra was also considered the king of kings and the one who could bring forth order. The god was depicted in various forms, often represented by a solar disk. Another common depiction witnessed on the hieroglyphic inscriptions was a man with the head of a falcon. It is thought that the worship of Ra first arose in a town known as Inu. To the Greeks, this was the fabled Heliopolis, otherwise known as the city of the sun god. Today, this ancient settlement is found in a northern suburb of Cairo. But just where did this powerful deity come from? And what did ancient Egyptian texts tell us about the creation of the god of the sun? The creation of Ra. The creation myth of Ra was likely been in circulation for thousands upon thousands of years in Egypt. Sources can be found in the pyramid texts, tomb wall decorations, and other hieroglyphic writings which date back to the Old Kingdom over 4,000 years ago. While there are undoubtedly various renditions of the legend, the majority begins as follows. In the beginning, the universe was an infinite body of water, known as none, without consciousness, without thinking, motionless and eternal. From the vast nothingness, Ra willed himself into an existence from the chaos, becoming the firstborn god. Ra decided he would create children, so from nothing more than will and without a partner, he gave birth to Tefnut, the goddess of moisture, and Shu, the god of air. In return, his children gave birth to Geb, the god of earth, and Nut, the goddess of the sky. With this, the physical universe was created. Ra creating the sun, moon, and humanity. After the creation of Tefnut and Shu, the world was but an infinite ocean, and Ra decided that he needed light to shine on the world so he could keep an eye on his children. But to do so, he would have to create an eye that looks down on his children from above. So Ra fashioned an enormous eye and sent it off to scour the earth in search of his children. But upon returning, the sun had discovered Ra had created a second eye in its absence. Full of jealousy, the first eye became angry. So to appease it, Ra gave the first more power than the second. Thus, the first eye became the sun, and the second became the moon. Now that the world was created, Ra continued to allow gods to multiply, and celestial bodies began to fill the night sky. Eventually, humanity was created from the tears of Ra. As eons passed, however, Ra became displeased with this ungrateful race of humans who walked the earth. When he learned of the plots put in place by the humans against him, he decided that a drastic action must be taken. Ra gathered the other gods in council, and they concluded that humanity must be destroyed. So the gods sent Hathor to wipe out humanity, and she engaged in a brutal cleansing mission that killed hundreds of thousands of humans until but a tiny remnant remained. At this point, Ra decided no more bloodshed was necessary and allowed the remaining humans to live in peace. However, he was thoroughly sick of the human world and decided to retreat into the heavens, leaving the god Shu to rule over the mortal world. After Ra left the earth, Geb and Nut married, even though their creator restricted them from doing so. Ra soon found out, and in his wrath, he ordered Shu to separate them. Shu defeated Geb in battle and permanently separated the two. However, Nut had already fallen pregnant, and Ra decided she was forbidden to give birth during any month of any year. Seeing her problem, she begged the god of learning, Thoth, to help her. Thoth had a great idea and decided to gamble with the moon for extra light throughout the year, and won. This led to the addition of 5 full days to the Egyptian calendar, now resulting in 365 days. On these 5 days, Nut gave birth to Osiris, Set, Isis, Nephthys, and Horus the Elder. Don't miss to watch our video, Thoth, the Atlantean, and the Emerald Tablets, the Lost Knowledge. You will find it in our channel. The secret name of many eons came to pass, and Ra had stayed clear of.
This city will kill you the first chance it gets.
I need money. Where to fight tonight?
There can't be two of us.
I am here to fight like my people are watching.
Except when the medieval festival comes to town. Depart. Airbnb thine home. And getteth paid to get it away.
Earth. But Isis, one day, decided that she would go in search of the legend of Ra's secret name. The gods of Egypt believed that words held power, which is why many of them went by pseudonyms to ensure they kept their power safe. When she finally found Ra, he was old, feeble, and the shadow of his ancient self. As he sat upon his throne, drool ran down his chin and onto the floor below. Seeing this, Isis collected some of his saliva and combined it with a small handful of dirt. Using her acclaimed magic, she formed a venomous snake from this mixture. Ra was known for being a creature of habit and walked the same route each day to survey his incredible creation. Isis, knowing this, set a trap and let the snake loose on his trail. As Ra walked past the snake, it launched onto him and inflicted him with a deadly bite. Generally, Ra was immune to such attacks, but as the snake was made from his own being, he had no immunity against it and was soon in great pain. Following the incident, Ra called for his followers and told them he was severely wounded. He asked if any could provide him with a cure, but no one answered, as none could give him what he sought. After all the others had tried and failed, Isis told Ra she could help him, provided that he told her his true name. Sensing there was trickery at play, Ra answered, "I am the maker of heaven and earth. I am the establisher of the mountains. I am the creator of the waters. I am the maker of the secrets of the 2 horizons. I am the light. I am darkness. I am the maker of the hours, the creator of days. I am the opener of festivals. I am the maker of running streams. I am the creator of a living flame. I am Khepri in the morning, Ra at noontime, and autumn in the evening." Let us know your thoughts on today's video in the comment section.
This is a switch bike. No, this is a switch bike. In fact, any bike can be a switch bike, and we really mean any bike. All you need is a switch kit. It's lightweight, pocket size, connects to your handlebars, and boosts your ride with electric power. Switch is your bike electric.
The sun is a star. That's a profound statement, and one that's not really all that obvious. Those little sparks in the night sky are pretty, but don't look anything at all like the hot, blazing orb that lights up our days. It was a pretty remarkable intellectual leap to understand the sun and the stars are just different flavors of the same kind of object. The only difference is that the sun is close, but the stars are terribly far away, so they're fainter. Right away, let's clear up a misconception. A lot of people say the sun is a middle-sized average star, but that's not fair. Sure, it's somewhere in the middle of the size range of stars, but the vast majority of stars are dim red dwarfs, far smaller than the sun. By size and number, the sun ranks in the top 10% of stars in the galaxy. In our solar system, it's clearly the dominant object, brighter, more massive, and more influential than anything else. But what is it? The sun is essentially a big hot ball of mostly hydrogen gas. It's 1.4 million kilometers across, more than 100 times the Earth's diameter, and big enough that well over 1 million Earths could fit inside of it. And it's massive, 300,000 times more massive than the Earth, a staggering 2 octillion tons of gas. But if we want to truly understand the sun, we have to look into its heart. At the very core of the sun, conditions are hellish. The pressure is a crushing 260 billion times the Earth's atmospheric pressure, and it's a searing 15 million degrees Celsius. Under those conditions, hydrogen is completely ionized, which means the electrons in the atoms are stripped from their protons. This makes the core a thick soup of ultra-hot subatomic particles. In fact, the protons are squeezed together so hard by the octillions of tons of mass lying on top of them that an amazing thing happens. They fuse together. Through a complicated series of steps, the hydrogen atoms fuse together to form the heavier element helium. Along the way, some of the nuclear energy stored in those atoms is released. That amount of energy is described by Einstein's famous equation E equals mc squared, which states that mass can be converted into energy and vice versa. Atoms are pretty small though, so each helium atom made in the sun's core generates only a tiny bit of energy, but a lot of helium atoms are made. A lot. Get this. Every second of every day, the sun converts 700 million tons of hydrogen into 695 million tons of helium. The missing 5 million tons, the equivalent weight of 15 Empire State Buildings, is converted into energy, and that's a lot of energy. Enough, in fact, to power a star. It's equivalent to detonating 400 billion 1 megaton nuclear bombs every single second. That's millions of times the entire nuclear arsenal of our planet, every second. And that's why, even from a distance of 150 million kilometers, the sun is so bright you can't even look at it. Even from that distance, its heat can be felt on your skin when you stand outside. Hydrogen fusion occurs in the core of the sun. The energy released heats the gas above the core, but not quite enough to fuse hydrogen into helium. Further from the sun's center, the gas becomes less dense, and at some point, the heat pouring up from below makes the gas buoyant. It rises in the same way a hot air balloon on Earth rises. This process is called convection, and it's an efficient way of transferring heat. Huge columns of rising hot gas stretch hundreds of thousands of kilometers high, bringing the sun's internal heat to the surface. The gas then cools and sinks back down into the interior. We can actually see the tops of these columns packed together across the sun's face. Above the convecting layer is a much thinner, cooler layer very near the sun's surface called the photosphere, or literally the sphere of light. This is where the density of the material inside the sun gets thin enough that it becomes transparent. Light can shine right through it. At this point, the energy from inside the sun is free to travel into space. It's this light that we see when we look at the sun. The sun is a gas and doesn't have a solid surface, but the gas in the photosphere thins so rapidly compared to the sun's huge size that you can think of it as the sun's surface. And there's one final layer above that, the ethereally thin corona, sort of like the sun's atmosphere. It's less than 1% as dense as the photosphere, but actually much hotter. Temperatures there can reach over 1,000,000 degrees. However, it's so thinly dispersed that it's incredibly faint and can only be seen during a total eclipse or using special telescopes that block the intense light from the sun itself. The corona extends for millions of kilometers, and in a sense, it doesn't actually end. The corona merges into what's called the solar wind, a stream of subatomic particles moving away from the sun. It blows out in all directions, though mostly along the sun's equator. The speed of the wind is usually well over 1,000,000 kilometers per hour. Yes, seriously, and can reach speeds even much higher than that. When hydrogen fuses into helium in the sun's core, the energy is released in the form of light. This light immediately smacks into a subatomic particle, which absorbs it, converts a little bit of the energy into motion, and re-emits the light with a little bit less energy. The light works its way out of the sun this way, losing energy every time it encounters a particle, until eventually it gets to the surface and is free to fly away into the universe as a much lower energy photon of visible light. So how long does this process take? I've seen different numbers for it, some as much as 1,000,000 years. But a lot of those calculations don't model conditions inside the sun accurately. For example, they don't take into account the gas convecting for hundreds of thousands of kilometers. More modern calculations show that it takes closer to 100,000 or 200,000 years for the energy to work its way out. That's still a pretty long time. The light you see from the sun now got its start in the sun's core around the time Homo sapiens first appeared in Africa. The sun's surface is, to put it kindly, a mess. And the key to that mess is the magnetism. I've been saying the sun is made of gas, but that's not entirely accurate. It's so hot inside the sun that electrons are stripped from their parent atoms in the gas, creating what's called a plasma, a gaseous soup of charged particles. We'll learn more about that in a later episode, but what's important now is the fact that a moving electric charge generates a magnetic field. The interior of the sun is essentially all charged particles in motion. Convection, coupled with the sun's rotation, sets up rivers or streams of plasma inside the sun, each generating and carrying its own magnetic field. When this plasma reaches the sun's surface, their magnetic fields do too. Maybe you've seen those looping arcs of magnetism around a bar magnet when it affects iron filings on a piece of paper. The solar magnetic fields are like that, except there can be zillions of them all over the sun's surface, where they can interact and even get tangled up. When the plasma reaches the surface, it cools. But if the magnetic loops tangle up, they prevent the plasma from sinking back down into the sun, like a knot in a shoelace prevents it from going through the eyelet on your shoe. Plasma shines because it's hot, but as it cools, it dims. It sits on the surface dimming, producing a dark spot on the surface of the sun, which we call a sunspot. Sunspots can be huge. They commonly dwarf the entire Earth, and some are so big they can be seen without using a telescope, as long as you're wearing adequate eye protection, of course. Around the edges of sunspots, the magnetic field lines are concentrated. This can energize the plasma even further, heating it up. This creates a bright rim around sunspots called faculae, Latin for little torch. The dark parts of sunspots dim the overall light from the sun, but faculae can be so intense they compensate for that and even add more light. Ironically, sunspots actually increase the energy output of the sun. Plasma on the sun's surface can flow along these magnetic loops too. This can create huge arcs of material called prominences or filaments, stretching for hundreds of thousands of kilometers across the sun, looking like fiery arches. We think these magnetic field lines are feeding energy from the sun's surface into the corona, which is why it's so much hotter. It's not exactly clear how this happens, but scientists are following several leads right now. This long-standing mystery may soon be solved. Magnetic fields on the sun also have a huge amount of energy stored in them. You can think of them like very tightly wound wound in very stiff springs. But remember, these magnetic field lines get tangled up. If conditions are right, they can actually snap, in essence creating a gigantic short circuit. When this happens, all that vast energy stored in the lines explodes outwards all at once in an event we call a solar flare. Even an average solar flare is mind-crushingly powerful. A big one can release as much as 10% of the entire sun energy output. This explosion blasts out high-energy light and launches material off the surface of the sun at high speeds, sending it into interplanetary space. Another type of solar eruption is called a coronal mass ejection, or CME. It's similar to a flare, but if a flare is like a tornado, intense and localized, a CME is like a hurricane, huge and strong. Like flares, they form when tangled magnetic field lines erupt, blasting out energy, but they occur higher off the sun's surface. Both flares and CMEs eject material into space. Billions of tons of it, in fact. This blast of debris can hit the Earth, and when it does, there can be profound effects. Our atmosphere absorbs the high-energy light, protecting us. Also, the subatomic particles are generally deflected by the Earth's magnetic field, so we're okay. But if conditions are right, the Earth's magnetic field can interact with the particles. Massive numbers are funneled down into Earth's atmosphere near the poles, causing the air to glow. This is what we call the aurora, or the northern and southern lights. Depending on the shape of the magnetic field, the auroras can form spectacular multicolored ribbons and sheets. Not all the effects are benign, though. As the magnetic fields interact, they can induce very strong currents of electricity in the Earth's crust. This can overload power grids, causing blackouts. In 1989, Quebec suffered a massive power outage from a solar storm. The very first such storm ever detected was in 1859, and was also the most powerful ever seen. If an event like that were to happen today, it could cause worldwide blackouts and potentially be very damaging. Satellite electronics would be fried too, and we depend on those satellites for our modern civilization. In fact, in 2012, a huge storm, probably the equal of the 1859 event, blasted away from the sun in another direction, missing the Earth. Had it hit us, well, you probably wouldn't be watching this video now. We'd still be recovering. This is why studying the sun is so important. We depend on it for light and heat and the very basis of life itself, but it's entirely capable of knocking our society to its knees. Understanding it is critical to our future. The sun is the 2 octillion-ton gorilla in the room. We need to respect that. Today,
Giant sphere of unimaginably hot plasma. It has no solid mass, meaning it doesn't have a distinct solid surface like Earth. Instead, it is composed of layers made up almost entirely of hydrogen and helium, and so the surface of the sun is considered the first visible layer, called the photosphere. It reaches scorching temperatures above 5,500 degrees Celsius, making it hot enough to melt diamond. Sparsely scattered across the photosphere are also enormous dark features called sunspots, which are caused by disturbances in the sun's powerful magnetic fields. The magnetic fields are very active here, often tangling, crossing and reorganizing, frequently causing sudden, powerful explosions of energy called solar flares, blasting out into space at extremely high speeds.
Explosion that comes out creates an explosion that points inward. And that creates very high pressure and very high temperature. And under those conditions, you can take 2 atoms, light atoms, and merge them into a heavier atom.
Sweet.
That takes a lot of high temperature to accomplish. Because, let's take the lightest atom of them all, which is what?
I don't know, maybe hydrogen?
Hydrogen, you got it. So hydrogen in its nucleus has 1 proton. And helium in its nucleus has 2 protons plus 2 neutrons. So how am I going to create a helium atom from a hydrogen atom? So you got to get a bunch of hydrogen atoms together.
Is mostly composed of just 2 elements, hydrogen and helium. These 2 gases make up over 98% of all the matter in the universe. Hydrogen is the most abundant element in the universe, making up about 75% of all matter. It's also the simplest element with just 1 proton and 1 electron. Helium is the second most abundant element, making up about 23% of all matter. It has 2 protons, 2 neutrons and 2 electrons. These 2 elements were formed in the early universe just after the Big Bang. In fact, the universe was so hot and dense at the time that hydrogen and helium atoms were the only elements that could form. While hydrogen and helium may be the most abundant element, they are not the only ones. Trace amount of other elements such as carbon, nitrogen and oxygen also exist in the universe. So while the universe may seem simple with just 2 main elements, it's actually a complex and fascinating place with countless mysteries waiting to be explored.
وما أبي أحد مشلول صار له مالي مقطوعة ما صبر مالي حد مالي غير الله والله يفرج خيرك